We're going to do heat. And well, maybe we should make it red. How about heat today? Idea here is, well, first of all, hopefully everyone realizes that matter, we have some object, is made up of tiny little particles called atoms, right? They're just all in there. Atoms, atoms, atoms everywhere. Okay? Hopefully we don't have any atomic theory deniers here. We understand that everything is actually made up of tiny particles called atoms that are inside there. This idea is key to understanding what heat actually is. Now, heat's one of those things that everyone that has the capacity for language, basically, just kind of intuitively understands. Hot things are hot. We know what that means. But scientifically, what does that mean? Well, hot things and cold things differ in a fundamental way. And that way has to do with the energy of the things inside of them. Okay? So, here is a cold thing. Okay? And its atoms are moving around a little bit, but not very much. Just different ways. Okay? And then here is a hot thing. Its atoms are much more energetic. They're moving all around in all these different directions, all over the place. But that's sort of the scientific definition of hot and cold. Cold things, or colder things, have atoms that are less energetic. They're moving around less. While hotter things have atoms that are more energetic. Okay, it's a change in energy. Energy creates heat. We talked about that a little bit when we first introduced energy, how heat is a form of energy. So that's where we are right now. There are three fundamental ways to transfer heat. And those are conduction, convection, and radiation. Conduction, convection, and radiation. Okay? Conduction is when heat is transferred from one object to another. Let's see, there's a cold object. And we also have a hot object. When heat's transferred from one object to another, and they're in contact. So over time, those two objects would end up looking more like this, and their temperatures would equalize, sort of. We'd go from cold and hot to something in the middle. That's conduction, when things in contact with each other transfer heat between them. And how's that work? Well, because all of these little atoms that are moving around a whole lot are bouncing all around in here, and all these atoms are pretty still, but these agitated atoms bounce off these still atoms and lose some energy when they do that, and then these still atoms are getting bombarded by these energetic atoms, and so next thing you know, these are moving more than they were before, and these are moving less than they were before, until it reaches a point where they're sort of at equilibrium. That's how conduction works. Convection has to do with fluids and transfer of heat between them, and they move as they have different heats and things. You've heard of convection oven. In particular, convection has a lot to do with the way that the weather works on the planet Earth. So we're not going to talk as much about convection. And then the last one is radiation. Oops. Last one is radiation, which is when heat is dispersed through space, and the best example of radiation would be the sun. The sun radiates light and heat through space to us over here on the Earth. Right? Okay. So those are your three methods of heat transfer. Know which is which. You'll see that on a test. That's not hard. Alright, real quickly, I'll talk a little bit about temperature. I'm assuming we all know what temperature is, and we've heard of it before. Know that in science, when we talk about temperature, we use Kelvin. And Kelvin, the way that you figure out degrees Kelvin, it's just Celsius plus 273. So the degrees Celsius plus 273 degrees, and that's how you get Kelvin. We don't use Fahrenheit in science. We use Kelvin. Remember that 0 Kelvin is called absolute zero, and that's, you know, all atomic activity stops. No longer are the particles in an object energized at all. They're just still. So remember all that stuff. That's easy. Just needed to touch on that real quick. Alright, so remember that we're talking about heat. And the first thing I guess I need to point out is that the symbol for heat is capital Q. If Q is positive, that means we gained heat. We got hotter. If Q is negative, that means we lost heat. So a positive Q means a gain of heat, and a negative Q means a loss of heat. And when we have a gain or a loss of heat, then we're going to have a change in something. What changes when heat is gained or is lost? Well, temperature, which is going to be capital T, temperature. So when heat is gained or lost, temperature changes, and of course, just like before, delta T equals TF minus TI. It's the same thing delta's been all year. It still means that here, so that hopefully isn't too unfamiliar. Okay, we need one other idea here though, and this is something I think you've seen before in chemistry, but I'm really not positive because I honestly don't know that much about chemistry. The idea of specific heat. I'm pretty sure you guys do that in chemistry some. So it's basically how much energy it takes to raise a kilogram of something 1 degree. So how much energy it takes to raise a kilogram of some substance 1 degree of temperature. That's specific heat. And specific heat is, the notation for that is a capital C. And the unit of this is really weird. It's a joule per kilogram times Kelvin. Joules per kilogram Kelvin. It's a really strange unit. What was the unit for heat? Well, the unit for heat is energy, so heat is just a joule, by the way. And then temperature is, of course, measured in Kelvin, degrees Kelvin. So there are all our units. So that's the idea of specific heat. Generally, you're going to be provided with specific heat. We're not going to do, well, we'll occasionally calculate it, but it's not going to be a big deal. And there's not going to be really any chemistry involved, like no atomic numbers or anything like that. Okay? And so all of this Q, T, C, and there's one other thing that's going to be involved. Well, thinking about it, what do you think is going to be involved? What's going to affect how much the temperature changes depending on how much heat is gained or lost? Well, hopefully this makes sense. It's going to be the amount of stuff, which is mass. So our formula, I'll just tell you the formula. It's really pretty simple. Q, which remember is the gain or loss of heat. Positive would be a gain, negative would be a loss. Q equals mc, that's mass and specific heat, times delta T, the change in temperature, which was TF minus TI. Here's our basic formula for simple heat questions. And really that's all we're doing today. As far as the problems go, you're just going to be given what you got. I guess these are your possible variables: Q, M, C, Ti, and TF. So you may prefer to write this instead as Q equals MC times TF minus TI. I don't like that notation. I like delta notation better, but that's a matter of personal preference. So those are our 5 possible variables. On today's problems, you're going to be given any 4 of them, and you have to find the other one. So it's just a matter of rearranging this equation, which is really easy to rearrange. The only time it's sort of a pain is if you're solving for something like final temperature, which I'll solve that for you real quick. Let's divide by MC. So we're going to have Q over MC equals TF minus TI. Well, if we're solving for final temperature, we'd just add TI to both sides. So we'd have, I'll flip it around, TF equals Q over MC plus TI. That's how I'd rearrange it. That's one of the hardest ones. I guess solving for TI would maybe be a little bit harder, but you almost have it right here already. So this shouldn't be bad. Next time, and if you are an 8A person, I won't be here unfortunately, but next time we'll move on to slightly more complicated problems. They're not really difficult, but the formula is really ugly, where we figure out things like transfer between 2 objects. This is just for one object that changed in temperature. We can figure this stuff out. Next time we're going to go to 2 objects of different masses with different specific heats that have some heat transfer, and we'll talk about temperatures and stuff. So that's what you have to look forward to, some sort of unpleasant algebra, everybody's favorite.